Okay, so let's get started. And so we're on week 5. And week 5, I'm going to tell you about arrays, pointers, and recursion. So it's a lot of stuff to digest. And let's go through it. All right, so the first thing that I'm going to tell you is recursion. All right, so let's say, and just to refresh your mind, let's say I have a loop, right? So for int I is equal to 0, I is less than 3, I plus plus, and I can do cout I with a little space after, right? And that will do the magic. And then cout ndl, right? That was one way to do this. I'll show you. The other way to do this is I say int I is equal to 0 here, while I is less than 3, and then I do curly brackets. I'll throw this stuff here. Alright, I'm going to put a little, I'll leave it like that. So this is going to be cout 4, and the other one is going to be a while. Okay, and if I run this thing, it's a never-ending loop. Let me kill it. Come on, C-line. You should know better. There you go. Okay, so I do an I plus plus here. Run it again. All right. So the 4 is 0, 1, 2. The while is 0, 1, 2. Right? It's just a ways to repeat something, and of course I can do a do while also. So what is recursion? Recursion is another way to repeat things, but it's not as easily understood as iteration, right? So this was iteration using a loop, right? Iteration, okay, using a loop. And what I'm going to do is I'm just going to comment all these out. And I'm going to do the same thing, but now I'm going to do it using a function. So I go in there, I'm going to make a function, let's say void recurs, and let's say this thing takes an I, just like my loop, okay? And then in my recurse, I'm going to do it right here on the bottom. Okay, I'm going to do the curly brackets, and I'm going to do one of these couts here with the I. Alright, so if I call this thing one time, if I just say recurse, I don't know, what did I have? 0, right? And I run the program, you're going to see just a 0, okay? Which is no big deal, we already know this. Now, what I'm going to do is, I'm going to tell it, alright, if my I is less than 2, okay, I'm going to tell it, call yourself with I plus 1. Just like that. Okay, and now when I run this thing one more time, you get the 0, 1, 2. So how does it work? You're sending in the value 0, right? You're showing the 0. Is 0 less than 2? Yes, it is. Call yourself with 0 plus 1. So it goes back, calls itself one more time. Now I is 1, shows the 1. Is 1 less than 2? Yes, it is. Call yourself with 1 plus 1. Goes back, calls itself one more time. It shows you the 2 this time. Is 2 less than 2? No, so it stops. It doesn't call itself anymore. Okay? Does that make sense? Okay. Now, if it makes sense, then tell me, how would it look like if I just moved this here? So if my cout was here, I get 0, 1, 2, right? What is going to be my output if I put it there?
Just going to get the 2.
Okay, so one guess is it's going to get the 2. What other guesses you have? Any other suggestions? Huh? You second his guess? Okay, good. I like to do this for recursion. I like to have like a class full of people and then just ask everybody's guess, and normally nobody gets it right. So, any other guesses?
Would it not go? Would it not?
Okay, that's another guess. So we had a 2, we had a would not go. What else? All right, nobody wants to take another guess. All right, let me run it. 210. Now what's going on there? All right, so let me show you. I'm going to go in there. I'm going to copy this thing. All right, so the other one, the first one makes sense, right? It shows you the number, then if it's less than 2, it calls itself, it shows you the next number, but this one's confusing. And that's what I mean that recursion is confusing, so let me show you. I'm going to throw this in Excel. Okay, and I'm going to take a picture of this thing. All right, take a picture of this, throw it right in there. Okay, then I'm going to go in there, I'm going to take a picture of this, just these lines, and I'm going to paste it a couple of times. So I'm going to paste it one time here, and one more time here. Okay, so now let's have a look at this thing. So initially, I'm giving this thing a value of 0. In fact, why don't I erase this? All right, I'm going to paste it there. All right, so initially when I do my function call, which is this here, all right, I do this. All right, so that means that this value for I is 0. Okay? It would be nice if it lines up automatically to the left, but it doesn't. All right, so I'm calling it, it goes with a 0, and then let's get this here. Okay? So then it goes and it calls itself with, so this is a 0, then it calls itself with 0 plus 1. So the next time this thing is 1. Does that make sense? Okay. Then it calls itself one more time with a 2. Right? So this time this is a 2. Center it. Yeah? And then when it gets to the 2, this 2 is not less than 2, so it stops calling itself. It's going to show you C out I, which is the 2, right? And that we had that guess, the original guess was it's going to be 2. But then what happens is, as soon as that function ends, then as soon as this one's done, it comes back right where it was called from. So it was called here, it returns right after the call, and for this function has an I of 1. So as soon as this one is done, we return back to what it was called, and now it's going to show you the 1. Right? So it shows you the 2, then it shows you the 1, then it's going to go and do this one more time. Right? It's going to return to right after it was called, right here, right? And then this time the I was a 0. So it shows you 2 for this one, 1 for this one, and 0 for this one, and then it ends. Question?
So essentially the functions are being nested with the if loops, right? For the if statement, sorry. So you're calling one function that's nested within another function that's nested.
You could think of it that way, but yeah, it's the same function.
Right?
It's the same function that calls itself.
So kind of within levels.
Yes, exactly. So you can see the recursion it's not the easiest thing to understand. And this is just a tiny little C out that I moved from top to the bottom. Okay? What's the advantage of recursion? Is it any faster? Nope. Okay? If you actually run a loop and you run a recursive call, you're going to see that the loop runs faster. Not just that, but the way the functions are called, there's like in the memory, there's like a stack, and you have to push on the stack every time you make a call for the function. So if you have a bunch of recursive calls, it will crash, right? So it's not very efficient, and it might end up crashing your program. So why would you do that? Because sometimes there's certain sorting algorithms that require, not just sorting algorithms, but there's certain problems that are just easier solved with recursive thinking, right? So one example is, let's say, sorting algorithms. And let me find a picture of this thing. This here. I'm looking for merge. Okay. Merge, sort. So if you Google merge sort, you look at Wikipedia, sorting is something we haven't done, but basically you get a list of numbers, you split it into halves. These are all recursive calls. So you're telling it, keep calling yourself, but every time you split the list of numbers into halves and halves and halves until there's just a single piece left. And then on the way back from the recursion, from the recursive calls, you're telling it to assemble itself in the correct order. Okay? And this is actually a lot more efficient algorithm than the bubble sort, which is something that I'm going to show you. That's something, well, I need to show you arrays first, and then I can show you the sorting mechanisms or algorithms. Okay? So bottom line is, it's just for simplicity's sake to solve some of these, algorithm or these real world problems. That's where we use recursion. So you really need to understand recursion in order for you to do data structures, and you really, 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 really need to understand arrays before you can do data structures. So what I'm going to do is, I'm going to go in there. So I already told you about recursion. Pointer example. So let me tell you about pointers, right? Because I got to tell you about this.
Aren't pointers as bad as a global variable?
No, pointers are not as, they're not the same thing. Yeah, it's a way it is a way to change a variable from one location of the program into another. So it's like a workaround for global variables, which you shouldn't use because it's bad practice, right? You don't want one part of your program to mess up another part of your program accidentally. Okay, so from what you have learned so far, so we already know the recursion, right? So we know how recursion works. Good enough. Now let's have a look at, let's say I have a void, I'm going to call it no change. I'm going to have an int a in there. And then I'm also going to go and I'm going to declare, I'll do it at the bottom. All right, I'm going to do it right here. Int a again, right? And this a is going to be equal to 10. Okay? And then in my function definition for the no change, right, no change, I'm just going to say a is equal to 0. Okay? And then I'm going to do this. I'm going to say no change a, and I'm going to do cout a equals a and o. Right? So the name kind of gives it away, but what do you think is going to be the value of a when I do a cout here?
10.
10, right? Because this thing, even though I'm changing a, so what? This little a here is not the same as this little a there. They're two different variables. They refer to different places in memory, even though they're the same variable. Okay, so let's just check. And maybe I should do a new line right before. Right, you can see it's 10. Okay. But there is a way for me to change the variable a from inside of a function. So I'm going to make another function. Alright, and this time I'm just going to put like a little asterisk in front of it. And I'm going to change it to change. Okay, let's see if I remember my syntax. Throw that in there. Okay, so this is my pointer a. And in here I'm going to do, I think it's asterisk a is equal to 0. Alright, and then I'm going to do change. And this time I'm going to do ampersand a, and I'll tell you what that is in a second. And then I'm going to do the cout again. This, there. Alright, and run it again. And this time it's a 0. Okay? So what is the ampersand a? Let me show you the ampersand a. Cout, and I think I already showed you, the memory address of a is ampersand a. Okay? And L. And if I run this thing, right, this long number right here is just some place in memory in your RAM that A refers to.
Is it always
Okay.
random?
Huh?
Is it always random?
This number?
Yeah.
It depends on what's taking up memory. Yeah, it will be kind of random. Because, I mean, sometimes you could run the same program a bunch of times and it will refer to the same places in memory. but maybe if you open up a bunch of other programs and then you run your program, then now memory is filled up with other things and you can no longer refer to that same place, but you got to move down somewhere else. Yeah, so it's not necessarily random, it's just it refers to whatever's available right now. Okay? So what does the asterisk A refer to? So asterisk A is a pointer variable, right? So asterisk A is a pointer variable which refers to the memory location of another variable. Okay? So when I say %A, I'm actually sending over this memory address of A. This variable A points now is referring to the same memory address as this A in the main. And by doing asterisk A, I'm actually referring to the original location. Okay? So let me go back to the Excel kind of again. All right? So let me do another sheet in there. Okay, so let's say I have if you have in your main, you have int main, right? And in it you have a variable A. Okay? And then in here in no change, and by the way, let's do cout in no change, and I know it might mess with me just to throw me off. In no change, %A is %A, and they'll. Okay, good. Wait. So in no change, this is the memory address of A. So you can see that even though this thing here is called an A, and my main is also an A, they're two different locations, right, in memory. So if I go in there, and I'm going to copy this thing here, right, and no change, yeah, I'll do it like this. So no change A, right, and the memory address is, oops, then copy the right thing. Copy as plain text. So this is in no change, and this is the memory address of A in the main, right? So there are two different memory locations. So basically, A refers to this memory, A refers to this memory location. When I go in there and in my main I say A is equal to 10, I'm changing the value that is stored inside this memory location. Okay? When I go to my no change and I say A is equal to 0, I'm making some other place in memory, you know, the whatever number is stored in this place in memory is just this, but that does not change the original A inside my main. Okay? When I go to my change function, right, which has an asterisk A, what asterisk A refers to is, insert, asterisk A refers to, basically points to this, right? That's what a pointer is. Okay, so the asterisk A refers to this memory location. So if I wanted to change this memory, if I wanted to change this place in memory to something else, I use the dereference operator. That's what this little asterisk is. Okay? And if you think this is confusing, there's double pointers, there's a left pointer, a right pointer, and then there's all kinds of other pointers in there in the C++ language that you don't even want to know. Okay? That's one of my least favorite things in C++, these pointers. Okay, if you take Java, the Java developers said, you know what, screw pointers. We're not going to do any pointers whatsoever. So the whole language just got rid of the pointers. Can you do things? Yep, you can still do things, but you just don't need to use pointers. Okay? But anyway, the moral of the story is, and the practical application that we're going to be using these for is, if you wanted to change your variable that is declared in the main from inside of another function, you use pointers. Okay? Any questions? Yeah, it's a lot of information. Don't worry. I'm not going to do a whole lot of this, but I want you to be aware of it because this is something that we're going to start using in the data structures class. Okay? Question?
Why would you, so I've actually been reading other books, and what are the benefits of this as opposed to passing by reference?
Passing by reference. Okay, so there's like I said, like they were not happy with 3 kinds of different pointers, make that 4, but now they wanted to add another way to do this. And the pass by reference. Okay, so the pass by reference. Let's do this. Change to int %a, like that, right? So this one here is pass by pointer, and this one is pass by reference. It's basically doing the same thing, except with a pointer. Okay, so I'll show you. So all right, so let's do this. Change to, and this for change to, I'm just going to send a like that. All right, so it's a different syntax again. So this is pass by pointer, and pass by reference. Okay, so pass by reference, it's basically when you have a pass by pointer, I can go in there and I can say, well, a is equal to some other variable. So if I have a pointer, I can repoint it to another variable at some other time. When I'm using a pass by reference, it's tied with that one memory location. That's really the difference. So one you can dereference the pointer. Yeah, the pass by reference is always tied with this memory location of the thing we gave it to originally, and the pass by pointer, you can dereference the pointer. You can point it to some other place. Okay, so this is change. Let's do change to, pass by reference, void change to, and it's int %a. And again, the syntax is slightly different. Let's see how it goes. So I'm going to go a is equal to 99, and then I'm going to copy paste this thing again right here. So the last a should be 99. Okay, so it basically does the same thing. It allows you to, both of them are ways to change the original variable. This one here, a pointer, you can repoint the variable a from inside here. I can say, well, a is equal to some other memory address. Okay, I cannot do that to my pass by reference. Okay, so yeah, 2 different ways to do the same thing. One is pass by reference, pass by pointer. Excellent question. Okay, all right. So pointers. Let's see what else I have in there. What examples I have. Yeah, this kind of a stuff. Oh, I actually show you pass by reference, and I'm calling it pass by pointer. So I'm not doing a good job naming these things. Okay. So this example here is not a pointer example, it's a pass by reference example, really. Okay? But now you know better. Okay, so any questions on any of this stuff? Pass by pointer, pass by reference, we did the recursion, and that's all I can say about that pretty much at this point. Okay? All right, so now what I'm going to tell you about is arrays. Okay, so that's pass by pointer, pass by reference, and now we're going to do arrays. Okay, and why did the programmer quit his job?
Wanted a raise.
He didn't get a raise. Okay, so we're going to do some arrays. So all right, so first of all, let's have a look at the example arrays intro. So I can remember the freaking syntax. There you go. Okay, so first of all, an array is just, let's say I wanted to declare a bunch of variables. I wanted to do something like A1, A2, A3, like A1000. Okay? Obviously, I'm going to have to type a lot of A's. I don't want to do that. I need a different way to do it. Okay? So instead of doing this, what I'm going to do is I'm going to say int A1000. And that's it. Alright, so what did I do? I created an integer array. So declare an integer array of 1000 elements. Okay? Let's have a look at these elements. So let's do this. Look at the first element of the array A. See out. I'm going to call it A square bracket 0 equals, alright, and this is A square bracket 0. Alright, let's have a look at what's that. Run it, and actually it's nicely 0 this time. Don't count on it being 0. Okay, and again, the A square bracket 0 is just like a variable A1, and it refers to some place in memory. You could have a 0 in that place in memory. You could have some total garbage in it. Okay? So this is look at the first element of the array. I can do the same thing with the second. Let's throw some more in there so that hopefully it throws anything else other than 0. So this is array in elements. So this is first element. This is second element. This is third element, right? I gotta change this to 1, this to 2. Okay, and let's run it one more time. And they're all zeros for some strange reason. So I can use a loop. Let's go through this whole thing. So I don't want to go in there and write this thing 1,000 more times or 997 more times. I'm just going to say, all right, for. Oh, and by the way, this. So this here is the element. Okay, and this here is the index. Okay, the indexes of array, so let me put it here. So the indexes of an array of 1000 elements are going to be 0, 1, 2, all the way to 999. Okay, so it never goes to 1000 because it starts at 0, including the 0 plus 9, or all the way to 999. That's 1000 numbers. Okay, if I do a loop, I can make a loop which is going to change my index values, right? So I'm going to go in there, I'm going to say, all right, for int I, let's call it index, is equal to 0. Index is less than 1000. And remember, it's never going to get to the 1000. I'm going to stop one before. Index plus plus. And then I'm going to do a cout right here. And I'm going to change this thing to like a little I or index. And I'm going to fill in index in the square brackets. Okay. And I'm going to run this thing again. And it should show me 1,000 lines. And see, there's some garbage in there. They're not all zeros. Okay, so I'm happy it showed that. So there's a lot of zeros, but don't count on it being zeros because there's not always going to be zeros. There's going to be some garbage in there. And sometimes it's going to start with garbage and it's all going to be garbage. Okay, so now you know, we can see that there's a bunch of crap inside of this array. So why don't I do this? I'm going to go in there and I'm going to initialize. So show the whole. This one here was show the array using a loop. Okay? And now what I'm going to do is I'm going to initialize the array to zeros using a loop. I'm just going to grab this whole thing here, recycle my code. And I'm just going to change this, no cout this time. And I'm going to make it equal to 0, right? Now they're going to be all zeros. And that's one thing you should do. Just make sure that you initialize your arrays before you start doing some kind of a math with them because you're going to end up, adding up this garbage values every once in a while. Okay? So I'm going to grab this. I'm going to do it again. All right. I'm going to do it right after. What do I do? Copy it one more time. Okay, and if I run this, maybe I'll show them all on the same line, followed by a little space. Okay, I run this thing, and now you're going to see there's 1,000 ones in there. Okay, so I zeroed the whole thing out. Okay, so that's initializing an array using a loop.
But you set it to 0? Is that what
I am setting it to 0. So set every element equal to 0.
that's
Set
1,000 of them.
every element equal to 0.
This isn't necessary if you're assigning a value to your array.
Yes, if you're going to be assigning some values at some point, you don't need to zero it out initially. Yeah. Okay? So basic terminology again is, declaring an array element, right, which is identified by its index. The index starts at 0 and it goes to 1 less than however many things you said this thing is going to have. Yeah, and you can use a loop to go through the thing. You can use a loop to initialize it and display it. All right. So next thing is, what else do I want to tell you about arrays? All right, there's another way to initialize an array. So you can do, declare an array, or another way to declare an array. All right, let's say I'm going to have an int b this time, square brackets, equals, and I'm going to do 1, 2, 3, 4. Okay? Just like before, this time I am declaring an array of 4 elements. So declare an array, declare and initialize. And initialize an array of 4 elements. Okay, if I am specifically writing down what the elements are going to be, I don't need to tell it how many of them there are. It will automatically figure out, oh, there's 4 things in there, and it's going to do it. Right? It's basically, don't put the number 4 in there if you're going to do this. Okay? Make sense? All right, let's show the different elements again. Show the elements. I do cout b square bracket 0 equals b0 and L. And let's see them. 1, 2, 3. 1, 2, 3, and then just to remind you, right, the index is going to be 0, 1, 2, 3, right? Those are my indexes. So let's have a look at this thing. Maybe I should do a new line. Oh, I already did. There you go, 10, 20, 30, 40, right? Be careful not to give it things that are not in there. All right, so for example, all right, try to use an index out of range. Okay, and nicer languages like Python and Java will actually give you an error about this thing. C++ won't. It just won't work. It might crash, right? Let's just have a look at what's in 4. What do you think is going to be in there? Whatever, right? Could be whatever. Your guess is as good as mine. Oh, it's a 0 again. Right? Could be a 0. Okay, but be careful because you could tell it to go too far and look at some place in memory which is not really in the array. Okay? So this is no good. Don't do this. All right? So don't do this. Okay? So, and again, the index out of range error doesn't even exist in this language. It just crashes left and right, or it doesn't work, which is worse. Okay, so let's see what else I want to tell you about arrays. So I told this is the intro, and arrays example. Yeah, they have some examples, so basic stuff. Okay, so just a little more examples. I can have a loop and ask the user to enter information into my array. In fact, maybe I'll show you the sort thing today. Yeah, I'll do a sort. Okay, so let's just do, first let's get the user to enter some information. So cout, enter numbers into the array. Okay. And I'm going to do for int I is equal to 0, I is less than 3, or not, 4, I have 4 things, I plus plus. And in here I'm going to tell them, maybe I should put this there. Enter number into array. I'm going to do square brackets, and inside here I'm going to do an I, like that. Right? And in here I'm going to do cn. This is b, let's call it b, into bi, b square brackets I. Right? And then after this, I'll get this loop, and I'm going to show you the values of I now, or b, cout, b, and let's show it a little fancier, so b square brackets, and the I is going to go in there, okay, and then I'm going to show you is equal to bi, end L, okay? So maybe I should put a little this one more time. Okay, so please enter a number into B0. That's this piece here. So I'm going to give it like a 1, 2, 3, 4. And there you go. So user input into an array and then showing whatever's inside of the array. Okay? Any questions?
An upcoming question is show that in reverse order. Does that just change the
Okay,
increment?
good question. Let's do that. So we're going to do show the array in reverse order. Alright?
I'm assuming that's just the for loop counting down.
Yeah, so help me with the for loop. So int I is equal to what initially?
4.
Okay, but remember, there's no index 4.
Three.
So it's got to start at 3. Yep. So it starts at 3. And then while my I is greater than or equal to 0, and then I minus minus. Alright? Copy this, throw it in there. I'm going to put this in a cout. Cout this. Alright, and a little endl in there. And then run it again. And then I'm going to do 1, 2, 3, 4. And there you go. Now it's in reverse order. Okay? Good question. Anything else? Any other questions? All right. So that's my array input output. Let's do something else. Let's say I have another array, and what I'm going to do is I'm going to take out this thing here. Alright, because I don't want to enter stuff into my program anymore. Okay, so what I'm going to show you now is I'm going to show you the bubble sort. Bubble sort. Okay, what I want to do is, let's say I have int C is an array which is 4, 3, 2, 1. Okay, and what I want to do is want to sort this array in ascending order. So it's what is it complaining about here? Expression expected. Oh, it's curly brackets. Curly brackets. All right. So I want it to go and be 1, 2, 3, 4. Okay. So how am I going to sort this thing? Let's have a look at. Let's ask Google. Bubble sort. Alright, bubble sort is, so let's say we have a list of numbers or an array of numbers. They're in random order. All we're going to do is we're going to compare two numbers that are next to each other, and if the one that's on the left is bigger, we're going to swap their values. So is this bigger than this? Yep, swap their values. Then it goes over to the next one. All right, is 6 bigger than 8? Nope, leave it as is. Go to the next two. Is 8 bigger than 7? Yep, swap their values. Right, so when we do this, from the beginning all the way to the end, what's going to happen is the biggest number is going to move all the way to the right, or it's going to bubble up to the top. That's what's called bubble sort. Okay? And then when we're done with this, when it goes all the way to the right, now we're going to go back all the way to the beginning. The biggest number is already moved all the way to the right. We're going to do this one more time. Is 5 bigger than 3? Yep, swap their values. Keep going, keep going, keep going. When we get all the way to the end, now the 7 is going to land in the second place to the right. Okay? Does that make sense? Okay, so this is what we're going to do for our sorting. So let's, and by the way, there's another picture that shows this. Another graphic. And give it a second to reset. So you have a bunch of numbers that are scattered all over the place, which is this originally, and then you just start sorting them largest to smallest. Okay? So that's what we're going to do. Alright, so I'm going to turn this off, and let's go look at my code. Okay, so before I do any of this business, let's have a look at how we swap values, because we need to understand how to do this. So swapping values. Let's say I have a value, let's say I have an int x is equal to 1 and y is equal to 2. Okay, what I want to do is want to swap the values so that x is equal to 2 and y is equal to 1. How do I do it?
You need the third storage.
I need a third one, right? If I just did x is equal to y, what happens? You have x is equal to 2 and then y is equal to 2. I lost the 1, right? If I went and I said, well, y is equal to x, then, and I didn't do this here, right? Then I would have my y is equal to 1 and my x is equal to 1. So I lost the 2. Okay, so before I do either of these, what I have to do is I have to make another variable. Let me go and call it temp. Okay, so what I'm going to do is, let's say I want to do it for this one here, right? So I'm going to say temp is equal to y, then y is equal to x, and then x is equal to temp. Right? So when I do this, temp is equal to 2. When I do this, y is equal to x. So now y is equal to 1, x is equal to 1, which is okay because I saved the value of y. And then the next one here, when I say x is equal to temp, now x is equal to 2. X is equal to 2, y is equal to 1, and then temp is equal to also 2. But we only care about these two, and you can see that I swapped them. Okay? Make sense? Any questions? Okay, so this is swapping values. What we're going to do is, we're going to do this for our array elements. Okay? So I go in there and I'll do this. I'll say, first I'm going to do an if. So swap if, let me put a third one so it's green. So swap only if the left element is bigger than the right element. Okay? So it goes like this. So my array is C. So if my C0, and this is what I like to do. I like to just start with something really small and simple and do this a couple of times so that I can establish a pattern so I can see it. And then based on that, I'm going to summarize it, make it a more general solution. So we're just going to write it out for all these 4 numbers. Okay, so, or 4 elements. So C, if the left one is bigger than the right, is bigger than C1, I'm going to go and I'm going to swap them. I'm going to say, all right, temp is equal to C0. C0 is equal to C1. And then C1 is equal to temp, right? Same thing that I did on top. Okay? So that's the first one. And then why don't I go in there and grab one of these here that I had. Copy this so that I can show you what it looks like initially. So this is cout initially, Alright, we do this, and I'm just going to do it initially this. I'm going to change this to C, and I'm just going to put a little space. Alright, well, just like that. And one here. Actually, let me do it another way. I'm going to do int I here. Int I is here. And we're not going to go backwards. We're going to start at 0. We're going to go while it's less than 4. We're going to go plus plus on this thing. And then I'm going to put commas in there. And then this is for these. And I'm going to get rid of this. And I'm going to throw another one here. And this last one is going to be a curly bracket, just like that. Okay? So I'm going to do it one time here. Let's hope it works first. Maybe a new line. Alright, so initially it's 4 through, starts at 0, no, not less than 4, so I made it go too far, right? So this last one here is this one, so I'm going to make this less than, let's go 4 minus 1, so you know what's going on, right? It's 4 elements minus 1, because I'm going to do this one extra time here, right? I'm going to do a new line at the end of this, one more time. So initially it's 4, 3, 2, 1, right? Okay. Then after this first swap, I'm going to throw this here. Alright. After first swap, throw it again. Oops. I'm redeclaring I can't do that. So erase. Run again. Alright. After the first swap, the 4 moved. Right? Which is what I want. And what I'm going to do is I'm just going to grab this thing here now. So this is my first and the second. Alright, and I'm going to do this one more time. And this is first element, first and second elements. Alright, and now the next thing I'm going to do is, this is for second and third elements. Right? And just to remind you, the index is 0, 1, 2, 3. Right? So I already did the 0 and the 1, which is these first two numbers. Now I'm going to do the 1 and the 2, which is these two numbers in the middle. Okay? I go in there, I'm going to just change my 1 to 2. 1 goes to 2, and my 0 goes to 1. Alright, so now I'm comparing the second and the third. Right? And if I run this thing again, which I will, the 4 should move where the 2 is. Run it. And it did. Okay? Now I'm going to grab this thing one more time. Copy it. Paste it. Now I'm going to do third and fourth elements. Okay? The 2 goes to 3. And again, just a refresher, I'm comparing these two index 2, index 3, which is the last 2 digits. Okay, so the 2 goes to 3 first, and then you can go change your 1 to 2. Okay, and if I run it again, the 4 moves all the way to the right. Yes? Okay. So now what I'm going to do is, I'm going to go in there, and I'm just going to go and comment this out. Right? And I just did this so that I can establish this pattern so that I can easily see it. The next thing I'm going to do is, let's say I'm going to make a variable. Right? I'm going to go in there and I'm going to call this variable j. Right? J is equal to 0 initially. Right? And then on the next one, when I go here, right? J is equal to 1 here. And then when I go to the next one, right? J is equal to 2 finally at the end. Okay? So for an array of 4 things, J goes 0, 1, 2. Okay? And if I call this J, right? If this is my J, then I'm going to call this one here J plus 1. Right? If this thing here is J, which is the 1, then this one here is J plus 1. Same here, same as for all the other ones. Okay? So then I grab one of these here. I'm going to copy this piece here. All right, I'm going to paste it right here. And I'm going to make a loop that's going to change my j. So I'm going to go in there, I'm going to say, all right, for int j is equal to, it was initially 0, right? That's why I wrote it a bunch of times. So the j and the j plus 1. So j is equal to 0 initially, while j is less than 4 minus 1. And let's make it 4 is a size or something like that. So I'm going to call this here int size is equal to 4, right? 4 elements. Okay? So instead of 4, I'm just going to use size. So size minus 1, and then j plus plus. And I'm going to throw in a curly brackets in there somewhere. Throw all this stuff in it. Put that there. Okay, so I already said this is going to be j. This is my j. This here, let's just change all the ones to j. So this is j. Alright. And then another j. And this one here is j plus 1. That. And that, right? So now this loop repeats, loop to repeat the above swaps, or 3 swaps. Right? Does that make sense? If I run this thing, I should still get the 4 all the way to the end. Ta-da! Okay? Alright, so now the next thing. Now that I did this one time, how do you think I'm going to repeat it again? I just copy the same loop. I just grab this thing here. Alright, let's just go there. Paste it one time. If I run it, now the 3 moves. Right? If I go and I paste it one more time, now the 2 moves. And it's sorted. Okay? So I did this again just to establish my pattern. What I'm going to do is I'm going to take this out. Alright, just so you know where we're coming from. I'm going to grab this thing here, paste it in there, and I'm going to make another loop. I'm running out of letters, so this is going to be for int k is equal to 0. 0. K is less than, how many times did I do this? 3 times. As many times as I did the other one before. Right? So I need to repeat this loop as many times as I did my swaps before. So I can just literally recycle this stuff, most of it. So size minus 1, and then k plus plus. I'm going to throw in some curly brackets in there. Put this in here. Right? And that's it. That's your bubble sort. Bubble sort. Okay, so this loop makes the inner loop repeat. Okay, so I'll run it, and there it is. Now it's sorted. Okay, make sense?
If you were going to be tidy, would the inner loop decrease on its maximum size each time you looped?
You could do that. So basically the idea is you don't want to be going all the way to the end every time, right? You could reduce, so like the first time you want this thing to go all the way to the end, the next time you want it to go one less than that, etc., etc. But just for simplicity's sake, let's just leave it like that, right? Yeah, there's ways for us to improve this algorithm, this sorting algorithm. But whatever you do to it, it's not the most efficient algorithm, right? And the way you measure the efficiency of this thing is, let's say this happens about n times. And for really like if we're talking about really, really, really big numbers, this happens about n times. This also happens about n times. And then you have a bunch of swaps in there. But the efficiency of this sorting algorithm is n times n, which is n squared. And that's the big O notation. That's how we measure efficiency of the algorithms. This thing is n squared, which is the least efficient sorting algorithm. Okay, there's some other ones. There's a select sort. There's an insert sort. There's some other ones that improve the efficiency by reducing how many swaps you do, because the swapping also takes time. There's other ways to do this with the recursion that I talked to you about. The recursive one actually has an efficiency of n log n, which is a lot more efficient than, these first three sorts that I talked to you: select, insert, and bubble sort. The select, insert, and bubble sort are usually the first ones, not the usually, but they're the first ones that I'm going to introduce into the data structures class, and then I give you a little more advanced sorts after that, which is the quick sort and shell sort, and there's some other sorts there that, somebody got a PhD in developing that algorithm, so, don't, blame yourself if you can't figure it out and come up with it yourself. They're not easily understood. Anyway, but this is a very easy to write algorithm, bubble sort. Okay? So, that's pretty much all I can tell you about loops. On Thursday, I'm going to tell you how to send arrays into functions. So we're going to send the array into a function. That way I don't have to keep copy pasting this thing here. I can put that inside of a function, send the array into the function, and then just show the array using a function. Okay? And for your final exam, or the final exam, you're going to have to do basically just arrays and functions. So everything is going to be arrays and functions. So you got to get it down. All right, so this is that, and let's have a look at all these different problems in here, the 45 through 54. There's 9 of them. So let's look at them. So I have 45 first. And you have a situation where you have a function sleep in with 2 parameters. One is called the weekday and the other one is called the vacation. The parameter weekday is true if it is a weekday, and the parameter vacation is true if we're on vacation. We can sleep in if it's not a weekday and we are on vacation, or we are on vacation. Return true if we can sleep in. Okay? So I'm going to do one of these. Right, so let's say you have, this is your hint for P45. I'll throw it at the bottom. So this is P45 hint. Alright, so we have, wrong thing, I copied. There you go. So this is my function. I'm going to send it a false and a false. The function takes in 2, and I give you the prototype. Here's your prototype. I'm going to throw this all the way at the top. Okay, this is your 45 hint, P45 hint, semicolon. Okay, and I'm going to go at the bottom under my main, paste this thing, curly brackets. Okay, so how does it go? So if it's a weekday, or how does it go? If it's not a weekday and we're not on vacation, so it's not a weekday, it's got to be a weekend, so that means you can return true, which is you can sleep in, right? So if it is not a weekday, doesn't matter if you're on vacation, really. Doesn't matter if you are, well, yeah, and you're not on vacation, and you're not on vacation. If it's not a weekday and you are not on vacation, you can false and false returns true. I'm not sure if that makes sense.
Because it's not a weekday, so therefore it implies it's a weekend.
That's right. So if it is not a weekday, it is a weekend. It is a weekend. But you're not on vacation, and you're not on vacation, you can sleep in, right? So I go if weekday is equal to false, or not equal to true, I guess, not equal to true, and my vacation is not equal to true, right? This whole thing is going to return true. Okay, make sure you put some parentheses around this so it doesn't create issues. And you do a few more ifs to do the rest. Question?
Can't you just show you equals false? Or?
You can do equals false, yeah.
Oh, okay.
Yeah, same as, what is it saying? Expression can be simplified to is not weekday. Yeah, okay, great. Okay, so yeah. The one way to do this is this way. Another way to do this is equals false. All right. Yeah, you can do that. Okay. In fact, this makes a little more sense. Okay. All right. So yeah, and you do the rest.
And
Do the rest.
Efficiency-wise on a compiler, aren't the equals easier than the nots?
It's the same thing. Yeah. Okay. So that's your P45 hint. Let's have a look at the next one.
Databases, that was the thing.
Databases.
Yeah.
Okay, so this one is, we have two monkeys, A and B, and the parameters A smile and B smile indicate if each is smiling. We're in trouble if they're both smiling or neither of them is smiling. Right? And there's a bunch of tests in there that you make sure that you test all these different ones. Right? So this one is, we're in trouble if, right? And let me get my prototype first. Okay, so this is your P46 hint, P46 hint, that's your prototype. Alright, there's your definition. Alright, so if A smile is equal to true and your B smile is equal to true, then you return true, right? You're in trouble. Okay? And yeah, it's going to tell me that I can simplify this, and I'll show you how to simplify it in a second.
So all we have to do is those for the other ones, is that it?
Yeah. You got to write a bunch of ifs, right? So this is one way to do this. And I can also simplify it, and notice how this thing is already telling me. It can be simplified to A smile. Okay, great. I can do this. Or I can do this. Now it's going to be less complainy. Alright? Because this is either true or false, right? So if this is true and this is true, then we return true. You don't have to say equals true. Okay? So that's your 46 hint. Alright, so P46 hint was we get these. And you have a true, like that. Okay? So that's the 46. Next one, 47. All right, and let me put a little comment in there, right? Do the rest. Do the rest. Okay. Now this one is sum double. Given two integer values, return their sum unless the two values are the same, then return double their sum. And there's a bunch of test cases for you to check and run this, right? So let me copy the prototype. This is 47. P47 hint. This goes there. All right. So you're basically supposed to return the sum of these things unless the two values are the same. Alright, so I'll just show you the sum, you got to do the rest. Alright, so the sum is, I guess, if value 1 is not equal to value 2, right, you got to return value 1 plus value 2. Yes? And you do the rest. Okay? And I can go in there and give it like, this is P47 hint. This is sum double. Let's give it a 1 and a 2, right? They're not equal. So this should work. Now keep in mind that actually the way I'm calling this thing is not right. I should be calling these from inside of a cout. Because the function returns a value. Where does it return it? Nowhere, right? So call it from inside of a cout. Does that make sense? Okay, if I call some double like this, we're going there and they're not equal, right? 1 is not equal to 2. We're returning 1 plus 2. It's basically, it goes in there. This is 1 plus 2, so it's returning a 3, right? So this whole thing becomes a 3 in here, but you're not showing the 3, right? And that's why you want to do a cout to show the 3 that's being returned. Yeah? Okay? So that's 47, 48, recursion, 99 bottles. All right, so you already I showed you the recursive business. You got to write the song 99 bottles of beer on the wall recursively. All right, so it starts with 99 and it keeps going until it gets to 0, and then when it gets to 0 you tell it no bottles of beer on the wall, blah blah blah, all that stuff. Okay? So I give you an example for recursion, and I guess that's your hint for 48. P48 hint, right? And what I'm going to do is it decreasing, the recursion? I don't remember how it was. Yeah, it's decreasing. So there you go. You got it in the correct order. Okay? So that's that. The next one, 49, the Fibonacci. Okay? What you're going to do is you're going to take parameter total numbers, 49. Alright, so this is P49 hint. Paste that in there. Okay, so P49. Okay. So you're going to have a loop that happens as many times as your total numbers. Alright, so you have for int I is equal to 0, I is less than total numbers, I plus plus, right? And always baby steps. Write these things in little incremental steps so that you can see what's happening. Right? First thing I'm going to do is I'm going to show myself what value of I is. So I equals I and L. Right? I'm going to run this thing. What did I do? I didn't call it. So I got to go call my function. This is P49 hint. I got to call my Fibonacci. And let's say I want to call it with 4 numbers. Okay? And let's have a look at it at the bottom. Maybe I should do some handles. Handle. And here. And let's try this. Alright, so it shows me the 0, the 1, the 2, and the 3, right? So all we have to do is we just have to add up these values. 0 plus 1, then 1 plus 2, then 2 plus 3, etc., etc. Right? So basically this value right here, you seeing these values? 0, 1, 1, 2, 3, 5, 8. The 1 here is equal to 0 plus 1. The 2 here is equal to the 1 plus 1. The 3 here is equal to the 2 plus 1. Okay? I don't want to give you more than that because then I'm going to solve the whole thing for you. Okay? But basically all we have to do is we have some kind of a sum variable in here, like int sum is equal to 0. And you just keep adding these values into the sum. That's all there is. Okay? And if you get stuck on that, let me know.
I tried to do a cout on a sum plus sum, and the compiler gave me a you can't do a binary in a cout.
You try to do cout sum plus sum?
Yeah. So, well,
Sum plus sum?
The two sum variables. They were different variables, but it was
Oh.
essentially that, like a sum one, sum two.
No,
kind
that
of
should be
thing.
fine.
It was spitting at me, so.
Yeah, it's working. You just have to keep adding them. So the sum initially is 0, then it's going to be equal to the 1 plus 2, then it's going to be equal to, right, et cetera, et cetera. You just keep adding these numbers into the sum, and that's it.
We switched the void function to an int function to make it work.
Show me, I'll look at it. We'll fix it. Okay, but that's all there is. Just add the i's to the sum to find the Fibonacci, right? And show sum every time. That's basically it. Okay, so that's your 49. Next one, 50, pointer example. I have an example in here. Let's call it reference example. Reference example, right? Type up the reference example, including the comments, submit the program and output, right? So nothing to give you, no clues to give you on this. Type it up, make sure it works, the usual. 51, MPG with a function. Write a program that will read the numbers of liters of gasoline consumed by the user's car and the number of miles traveled by the car. The program will then output the number of miles per gallon. So you have to get the liters, convert them to gallons, and then that's it. You divide one by the other and you're done. Anyone need clues on this one?
That was all pretty straightforward. The thing that was interesting was at the bottom, take input data for 2 cars and output which one, and output the number of miles per gallon delivered by each car.
So since this function returns a value, you can compare the MPG that this function returns and then see which one's more efficient.
Okay.
Yeah.
Essentially you're looping and having them.
You call the function 2 times and then compare. You can have like, all right, so let's do this. I'm not going to write the whole thing, but I'm just going to do this as 51. P51 hint, right? You got this thing. And then in here, you would do something like P51 hint. You're going to do, let's say we're going to have an MPG1 is equal to this, double, right? Let's say you give it like a, what's the mouse? So let's say whatever, 10 and 20. All right, that's the first one. And then you get this, paste it in there, and then change it to 10 and 30 or something. And then figure out which one's more efficient by just comparing this and this. Yeah?
Okay.
So that's that one. All right, so compare MPG1 to MPG2, see which one is more efficient. Okay, that's the 51. How many more do I have? 52, array example. It looks like you're just going to type up some example with arrays to get it working. Type up the array example and get it working, submit your code. The array example was this year. All right, so maybe I should throw that in there. Let me do this, save. Throw that away. Let me update the assignment. Edit. Throw a picture in there. I think that was downloads. Ugh, date modified. There it is. Upload. And here's your array example. So that's the 52. 53, array input output. I already showed you some examples of arrays input and output. So that is, where is this thing? Where did I have it? That's the piece of code that I commented out because I didn't want to enter anything. So this here, this is 52 hint. That's this one, right? Array input and output. And then the last one, arrays and random numbers. Okay, this one is interesting, and that one ties with that question he asked about how do we show this thing in reverse. Right, so first we're going to make an array with x numbers, where x is a random number between 20 to 30. And then we're going to fill the array up with random numbers between 100 to 200. So you don't know what numbers are going into the array. They're all random. You don't know how many numbers are going to be in the array. They're going to be between 20 to 30. You make the first array. This is your first array. Then you make a second array using the information from the first array, but you're doubling it. Right? So you're going to get this array, you're going to show it in reverse, you're going to pull every element of the array, you're going to double it, and you're going to make the second array, array 2, equal to that thing. Does that make sense? So this 324 is this times 2, this 270 is the 135 times 2, etc., etc., etc. Okay, so that was, where did I have that? That was this piece here. This is your P54 hint. Yes? Any questions? Okay, so that's it. As far as this week is today, Tuesday is concerned. All right, there's going to be a few more next on Thursday. I'm going to tell you about functions and arrays, and that is pretty much all the new stuff that we're going to cover. On Tuesday, I have a bunch of extra credits. It will be good for you to do them before you do the final exam. If you don't want to, that's fine. They're not going to count against you. And then the final exam is just arrays and functions. All right? How to find the lowest value, the highest value, some of these things in the array, the average value, the counting, how many things are in the array. I guess I'll show you that next time. Okay? I should have shown that. Let's do it. One more. One last one. So this is all the way at the end. Let's say I have an array Z. Right? So this is want to count how many times an element appears in the array. Right? So let's say I have an int Z, because I'm running out of names, is equal to 1, 2, 3, 2, 1, 2, I don't know, 0. Okay? So I want to count how many times 2 appears in the array. Okay? So I'm going to go and say, all right, for int I, how many things do I have here? 1, 2, 3, 4, 5, 6, 7. Next time I'm going to show you how to find the size of an array. So 7, I is equal to 0, I is less than 7, I plus plus, and then I'm going to do an if in there. So if my zi is equal to 2, right, because I'm looking for a 2, count 2 plus plus, something like that. Make a variable int count 2, make it equal to 0, right, and then I can show you cout. In fact, I don't even need the curly brackets. Let's clean it up a little. Right? I can tell you that there are count 2 2's in the array, and that's something that you're going to have to do for the final. All right. Oops. What did I mess up? Some of my functions are messed up or something. These are warnings, though. Oh, I think I'm redeclaring I. Let's call this something else. Let's call it M. Maybe that's why it's messing up. this is an M. Yeah. I gotta go figure out what's wrong with this thing. Undefined. These warnings don't have anything to do with the error message. I gotta figure it out. But anyway, this is how you count elements from an array. Okay? Take my word for it. Okay? Yeah. So I'll go troubleshoot what's the issue with this. All right. Any questions? All right. So these are the basics. You know how to look through an array. I'll show you. I guess let me show you how to sum the elements of the array. You can do int sum is equal to 0, and in here I'm going to have to add the curly brackets again. All right. I can just do your normal sum business. Sum is equal to sum plus zm. Okay, that's finding the sum of an array. Okay, finding the sum of an array, sum of the elements of an array, right? And then you know how to do the average. That stuff is easy. Okay, so counting, sorting, show you some other things next time. And that's all I have. We're good?
I had a question whenever you're done.
Okay. All right, so I'll unplug this so I can pause the video.